Okay, welcome. As you can see, we're going to be talking about sum and difference formulas in trigonometry. I do not have those listed down, but you're going to get a good feel for those as we move into this assignment. So let's take a look. All right, we are to find the exact value of this. So let me go ahead and list this one down. We have a formula for, see how we're doing here. We have a formula that says sine of A plus B is equal to sine of A cosine B plus sine of B cosine A. That might be worth jotting down if you don't have that listed down already. So this formula becomes sine of 2/3 pi cosine of 5/6 pi plus sine of 5/6 pi times cosine of 2/3 pi. And if you don't have those memorized, then those are probably triangles worth jotting down here. So let's take a look at our 2/3 pi triangle. I'll go ahead and just notate that, 2/3 pi. 2/3 pi, that is 2 rotations of 60 degrees, gets me to right here, 60-degree reference angle, where we could call this distance 1, 2, root 3, but this is to the left. And now let's take a look at our 5/6 pi triangle. 5/6 pi is 5 rotations of 30 degrees. Gets us into the second quadrant right here, 30-degree reference angle, 1, 2, root 3, but of course we're to the left. So let's go ahead and continue from there. So I need the sine of 2/3 pi. Sine from this angle right here is opposite root 3 on hypotenuse 2. This is root 3 on 2 times cosine from the blue triangle, cosine from this angle, x on r, negative root 3 on 2 plus sine of 5/6, sine from the 5/6 pi triangle, sine from the blue triangle is opposite 1 on hypotenuse 2 times cosine of 2/3 pi, cosine from the red triangle is adjacent, negative 1 on hypotenuse 2, or x on r. So we end up here with root 3 times negative root 3. That's negative 3. 1 times negative 1, minus 1, all of those on 4. And I get negative 4 on 4, negative 1. Let's see if that makes any sense to us at all. 2/3 pi, that is, if I go back up and look at this, because that's a somewhat surprising answer, but if I look at 2/3 pi plus 5/6 pi, that is common denominators, 4/6 pi plus 5/6 pi, that is 9/6 pi or 3/2 pi. It's starting to make more sense to me. Graph of sine looks like this at 1/2 pi, pi, 3/2 pi. We're down at negative 1. So I feel pretty good about that negative 1 answer. Again, the quicker way to do this, of course, would have been to just go ahead and combine those and realize, hey, we're quadrantal angle here. But what we're dealing with right now is our sum rule, our expansion of sine of A plus B. So there you go. Okay, now let's go back and take a look at this just for a second here. Here we were dealing with sine of 2 pi on 3 plus 5/6 pi. Remember those values. Now we're dealing with this. And what the author is trying to get across here is, I wonder if this is the same or equal to, I wonder if that's the same as sine of 2/3 pi plus 5 pi on 6. they're saying, I wonder if that works, that we could just kind of distribute sine through. So let's see if we end up with negative 1 when we do this. So once again, our 2/3 pi, that's 2 rotations of 60 degrees, gets us to this triangle. And our 5/6 pi gets us to this triangle. So sine of 2/3 pi, sine from here, opposite root 3 on hypotenuse, plus sine of 5/6 pi, opposite 1 on 2. So this is root 3 plus 1, all on 2, which is hardly equal to the negative 1 we got on the prior problem. But this is the solution to this problem, but hopefully we're noting that we cannot just distribute sine. If we could just distribute sine, like this was sine times instead of sine of, we wouldn't have any reason to bother with sum and difference rules. Okay, now we're to find exact values of sine, cosine, tangent of the angle. I might have to write kind of small to do this. I'm going to have another video out that's going to show an awesome shortcut for this, but we're going to go through the whole process right now. They are kind enough to give us this information. What the sum and difference angles allow us to do is find exact value of 15 and 75 degree reference angles. For instance, 195 degrees is 15 degrees right here. Now, typically what I do when we're finding those, if they aren't nice enough to give us that, is if we have a 15 or 75, I just go to the 45 in that quadrant, and you can see 45 minus this 30 degree angle that we would have, 45 minus 30 would get us to that 15 degree reference angle, or 225 degrees minus 30. So I'm going to go ahead and say sine of 225 degrees minus 30 degrees is, sine of a difference is sine cosine. So this is sine 225 cosine 30 minus sine cosine, switch the angles, sine 30 cosine 225 degrees. At which point you might want to draw the triangles out. So let's go with our 225. I'm going to make this fairly small. Our 225 gets us a 1 root 2, but this is down and left. There's our 225. And our 30 gets us a 1 2 root 3, where everything's positive. So sine of 225, in our 225, opposite on hypotenuse is negative 1 on root 2. Times cosine from the 30, cosine adjacent on hypotenuse, or x on r, root 3 on 2. Minus sine of 30, 1/2. Cosine 225 is also negative 1 on root 2. So if I rationalize these irrational denominators, I get negative root 2 on 2 times root 3 on 2 minus 1/2 times negative root 2 on 2. I end up with negative root 6. I don't know where that came from. Negative root 6 minus times minus plus root 3 all on, or root 2, excuse me, root 2 all on 4. Okay? And certainly if we wanted a decimal value, we could do that, but if we wanted a decimal value, we could just get that from our calculator. So assuming we wanted the exact value of sine of 195, there it is. Let's go through the cosine process with that. I think I have enough room to go through cosine. To find cosine of 225 degrees minus 30, we need the cosine difference rule. And the cosine difference rule is it becomes cosine cosine plus sine sine. Or in other words, cosine 225 cosine 30 degrees plus sine 225 sine 30 degrees. So our cosine 225, you can check real quickly, x on r from the 225 is negative 1 on root 2 or negative root 2 on 2. Our cosine of 30 degrees is root 3 on 2 plus sine of 225, opposite, negative 1 on root 2 or negative root 2 on 2, rationalized, times sine of 30, 1/2. And we end up with negative root 6 minus root 2 all on 4. Okay, and what we're going to start to notice is we just repeatedly get this kind of a formation where we get plus or minus root 6 plus or minus root 2 all on 4. And we're going to keep seeing those pop up as we do these 15 and 75 degree reference angles so often that it may make us want to explore how do we get out of that. Is there perhaps a shortcut to come up with this? So I'm going to clear a little space here and follow through with tangent of this using the tangent difference rule. But there will be another video that will discuss, can we come up with this in a shortcut manner that I think a lot of you might be interested in. So let me clear some space here just to come up with tangent. And again, there'll be a video that'll be maybe a part 2. It'll be on the website. If you didn't come here from a website and you're just a guest viewing here, there's a website you can get to, purpleshirtednerd.com. This will be, and that takes you to our pre-calculus website. And there will be this is in section 5.4, and you can follow the links to that video, or you may be able to find it searching through the YouTube videos. So let's go ahead and handle tangent. Tangent of 225 degrees minus 30 degrees. Tangent of a difference is the difference of the tangents. So tangent 225 minus tangent 30 over 1 plus the product of the tangents. Tangent 225 times tangent 30. So tangent from our 225 is negative 1 on negative 1. That is just 1. Minus tangent of 30, opposite 1 on adjacent root 3. So 1 on root 3 or root 3 on 3, rationalized. All on, I may regret doing that, let's see. All on 1 plus tangent 225, we found out that's 1, times root 3 on 3. And now it's just a matter of kind of getting out of this and simplifying this. So I'm going to maybe multiply top and bottom by 3 perhaps. Let's go ahead and try this. Times 3 on 3. This gives me 3 minus root 3 on 3 plus root 3, which I would argue, simplified sometimes is in the eye of the beholder. That's not too bad of a form to leave this in, but I'm going to go ahead and clear a little bit more space here and rationalize the denominator completely. Maybe I'm going in a roundabout way of doing this and you can get it done quicker, but let's go ahead and rationalize using our conjugate in the denominator. So we're going to multiply by 3 minus root 3 on top and bottom. And we get, in the numerator, if I FOIL this, I get a 9. First times first 9. I get minus 3 root 3s from my outside product. My inside product, minus 3 root 3s. And from my last, I get minus root 3 times minus root 3 plus 3. In the denominator, when I FOIL, difference of perfect squares, I get 9 minus 3. So I end up with 9 plus 3, 12. Minus 6 root 3, all on 6, how nice is that? 2 minus root 3. And what we're going to see as we do these tangent problems repeatedly of 15s and 75-degree reference angles is you're going to get these are always going to be in a form plus or minus 2 plus or minus root 3. And again, I'm going to have a video out there that's going to explain the shortcut to this, but I'm not going to put it out there until maybe we've done some of our homework on this, so we have to pay the price to find out. Maybe some of you can come up with what our shortcut method is for finding these sines and cosine and tangents of 15 and 75-degree reference angles. Okay, so here, let's take a look. 7/12 pi. We haven't dealt with twelfths much, but 180 divided by 12 is 15. That is a 15 degree. That's 17 rotations of 15. Let's just ignore this guy. You could split it up that way, but let's see if we can figure this guy out, kind of how we would handle this if they didn't give us the big hint. Oh, by the way, you can split 17/12 into 7/6 plus 1/4. So 17/12. 17/12. Well, I know 12/12 gets me to there. I know 18/12 would get me around to here, so I'm 1/12 or 15 degrees short of 3/2 pi. I am right in here, where this reference angle, or that's not a reference angle, where this angle would be 15 degrees and we'd be dealing with a 75-degree reference angle. That's where we're at. Okay, so what do I do? Again, they may have done this exactly as I have, but I go halfway through that quadrant. Halfway through this quadrant, I create this 45, and I realize I need 30 more degrees here to get there. So what am I dealing with? Halfway through that quadrant, this would be 180 and 45. This is 225 degrees. And then I need to add 30 degrees to that. And you can see those aren't the same values of these, but they get me there. Okay? All right, so let's go ahead and find sine of this angle. That is, and this turns into just the problem that we were just looking at, doesn't it? The problem we were just looking at, very, very similar. However, it was a subtraction problem. So here's our sine of a sum. Sine of a sum becomes sine cosine plus sine cosine, switch them. And you can draw your triangles for this, but sine of 225 degrees is negative root 2 on 2. Cosine of 30 is root 3 on 2. Sine of 30 is 1/2. And cosine of 225 is negative root 2 on 2. Okay? If you don't have those memorized, truthfully, I'm just kind of referencing back in my mind to the previous slide. So we end up with negative root 6 minus root 2 all on 4. And there's that pattern that I spoke of before. Okay? Let's take a look at cosine. So cosine of 225 degrees plus 30 degrees. That would be cosine of a sum is cosine cosine minus sine sine. So this is cosine 225 cosine 30 minus sine 225 sine 30. Cosine 225, negative root 2 on 2. Cosine 30, root 3 on 2. Minus sine 225, negative root 2 on 2. Times sine 30, 1/2, and I get negative root 6 plus root 2 all on 4. And there's our pattern again. We just consistently on these 1575s get this pattern, plus or minus root 6, plus or minus root 2, all on 4. Okay? Now, let's go back and let's find tangent of that angle. So I'm going to clear some space out again. Remind you at this point, as I'm getting this space cleared, that we will have some shortcuts for this after we've paid a bit of a price finding these things. So what is our rule for tangent of a sum? We're going to find tangent of 225 plus 30 degrees. Tangent of a sum is the sum of the tangents. Whoops. Tangent of 30. Sorry. All on 1 minus the product of the tangents. So tangent of 225, well, that's 45 degrees in the third quadrant. That's 1. Plus tangent of 30, that is 1 on root 3. I'm going to do this a little bit different way than I did the last one. All on 1 minus the product of those two values, 1 times 1 on root 3. What if I was to take this and multiply this by root 3 on root 3? I would get root 3 plus 1 when I distribute on root 3 minus 1. And now let's go ahead and rationalize that. I'll multiply top and bottom by the denominator, root 3 denominator's conjugate. And do some FOILing here. Create a little bit of room. And in the numerator, I get root 3 when I FOIL. First times first, root 3 times root 3, 3. My outside product gives me a root 3, another root 3 here, plus 2 root 3. Last times last, 1 plus 1, or 1 times 1 plus 1. All on my denominator, I get 3 minus 1. So I end up with 4 plus 2 root 3 on 2, or 2 plus root 3, which should look somewhat familiar to us. Take a look at that form versus what we ended up with down here on the previous slide. So that's a form that's going to become predictable. I challenge you, see if you can come up with ways of predicting what our solutions for all of our different 15 and 75 degree reference angles can be throughout the entire rotation. What are all of those going to be for sines, cosines, tangents? It's going to be really, really slick, and some of you are sharp enough. I know you can figure out how to utilize those patterns. Okay, find the exact value. Here they tell us sine of u is 5 on 13, cosine of v is negative 3/5. They tell us both of these are in quadrant 2. So I'm going to go ahead and draw a representation of angle u here. Angle u has a sine value of 5/13. Therefore, quick Pythagorean, that's a family. This is negative 12. Now let's go ahead and draw angle v. It's in quadrant 2, and it has a cosine value of negative 3/5. Are these drawn to scale? Well, they might be close, but not that important. Negative 3/5 cosine value. That's a family as well, conveniently. So we are just supposed to find, mercifully, just cosine of a difference. Well, cosine of a difference, the formula is cosine, cosine plus sine, sine. Cosine v, cosine u plus sine v, sine u. So now it's just a matter of picking off our values. So cosine v from the red triangle is x on r, although that was already given, negative 3/5. Sine from the red triangle, 4/5. Cosine from the blue triangle, from the blue triangle u, cosine x on r, negative 12/13. And sine of u from the blue triangle, 5/13. And we end up with positive 36 plus 20 on 65, or 56/65. In a lot of ways easier than what we were just doing. Write the trigonometric expression as an algebraic expression. Okay. Sine inverse x. I think I better draw a triangle to represent this. Again, this x is a ratio. What do we put into inverse trig functions? Ratio, perhaps x on 1. So I'm going to draw, here is sine inverse x. I'm going to place this in the first quadrant. That would be sine inverse x, or x on 1. That would be an opposite on hypotenuse of x to 1. Let's go ahead and draw a tangent inverse, or let's find the angle for tangent inverse. Whoops, I wanted to make that red. Try that again. Tangent inverse 2x. Well, this is opposite on adjacent. Opposite on adjacent 2x to 1. So if I let's call this angle A minus angle B, and I'm finding cosine of that. Well, here is my angle A right here, and here is my angle B. So cosine of a difference is cosine cosine, cosine A, cosine B, plus sine sine, sine A, sine B. So I think I better solve our triangles here. This triangle, this value right here, would be 1 squared minus x squared, the square root of that. Square root of 1 minus x squared. This missing value right here would be the square root of 2x squared, that's 4x squared, plus 1, Pythagorean theorem. So cosine of A, cosine of my top triangle, adjacent on hypotenuse, times cosine B, cosine from my other, adjacent on hypotenuse, plus sine A, sine from my top triangle, x on 1, times sine B, 2x on square root 4x squared plus 1. What a mess. And I end up with square root of 1 minus x squared plus 2x squared, all on our common denominator, 4x squared plus 1. You could rationalize this. Again, sometimes simplifies in the eye of the beholder. I suspect even the author likes the answer in that form. Okay, so if you're in my class, then these are the set of problems we're going to be looking at from this section. Again, want you to stay tuned because tomorrow I'm going to be adding a video that's going to shortcut that 1575 reference triangles for finding sine of 15s and tangent of 75s, etc. So I think you're really going to appreciate that. But in the meantime, we're going to pay a little bit of a price, do some of the work by hand. If you're just joining us, welcome. Hope you stay tuned. Hope you got something out of this, and good luck to everyone.